All right, let's talk a little bit about some plastic parts that you might think are injection molded but are not. So let's look at this part first. It's a water bottle. I'm sure you've seen thousands of these around. And what do you think? Is this an injection molded part or not? Well, it's kind of a trick question because there are multiple parts that make up what is correctly called an assembly. This is an assembly of parts. And the main body is not injection molded. It's made with a process called blow molding or blow injection molding, but it's similar to injection molding, but it's a little different. We'll get into the specifics of that later on. However, the head is made up of injection molded parts. So let's just take this off and take a closer look here, see what we can see. There's some nice texturing right there. We talked about how that's done in the tool. Zoom in a little bit more. These look like ejector pin marks here and here. And let's see if we can find a parting line anywhere. Oh, this is interesting. Okay, so you can see a parting line right here, but this is not a parting line between the A and the B sides of the tool. And I kind of use the terms tool and mold interchangeably. That's common in the industry, but this parting line is actually created. Do you know what? Do you know how it's created or why it's there? Let's think about that. How would this part be molded? And this is a separate part that was assembled after the fact. They were not molded like this. This part is the same as this part, different texture, so it looks a little bit different, but they're the same part. So pretty much everything gray that you see here is the same part. And how is that part molded? What direction were the tools pulling? So one tool is pulling in this direction, and the other tool pulled in that direction. So what does that mean for this little feature here? Maybe let's talk about what is that feature first of all. It's a little notch, and you can see that there's a catch in the lid here, on the cover. So when you close this, it clicks in place. There's a little tactile feel there, so the user knows his water bottle is now protected from the environment. All right, so this is a little notch. It's a little, recess into the plastic. So why might there be a parting line around it? Well, the answer is this is created with a side action. And just like when the core and cavity side of the tools meet and create a parting line, the same thing happens when the side action steel meets with the core or the cavity side. This is probably the cavity side since it's cosmetic, but there was a side action that pressed up against the cavity side of the tool and pulled in this direction. So it pulled away from the part in order to create this feature. And in so doing, it created that parting line that you see there. That's where that comes from.
So if I understand this one correctly, top, bottom, they separate, and there was one side action that went that way.
That's right.
Okay.
Yep.
Let
Yeah.
me take a closer look. Because if the two were to separate one way or another, if there was no side action, it would rip off the top right there.
That's right.
Okay, got it.
Exactly. Yep. If there was no side action, the cavity tool moving this way would just shear off any material above that little recess. So all this material right here would just be, all this material here above that recess will just get sheared off when the tool pulled away.
Perfect.
One other thing that I'll mention on this one is an overmold. This rubber area right here. So this is hard plastic, but this right here is rubber. And this is a common process that's used in injection molding when you want to apply a compliant or rubber-like material onto a hard plastic material. You'll see this a lot in various consumer products, but this is called overmolding. And you typically mold the hard plastic part first. That's called the substrate, and then you will move to a secondary mold that adds the overmold, the softer, the compliant rubber-like material. But this entire head is made up of injection molded parts. You can see all the little parts in here. These are all plastic injection molded parts that then get assembled into this head assembly. Okay, this is a pill bottle. And pill bottle is plastic. It looks like it was probably injection molded, but in fact it was not. It was also blow molded, just like the water bottle, except for the cap. The cap was injection molded, but the body itself was blow molded. And here you can see there's a parting line right there, all the way down the side.
So for blow molded items, there's also a parting line?
There is, yes. Okay, this is this black part here is a machined piece of plastic, and the question came up earlier: how do you know that this piece of plastic is machined and not injection molded? Well, one sign is you can see. Let's see if we can get the light just right. There we go. You can see some telltale texturing on this part, and if you didn't know what it was, then you might be confused, or there's just no way that a person would know what that is unless they were in the industry. But these are machining marks. So there's a cutter, and we'll talk about machining more in a different video. But there's a cutter that comes and cuts away material from the edge here, and that's what those marks are. That's from an end mill cutter, probably CNC machined. Another way that you can tell that this part was not injection molded was it is a big thick hunk of plastic, and big thick hunks of plastic are never injection molded. They are machined. So that's another clear indication that this part is machined, not injection molded.
But what about this one? Isn't this like a big hunk of plastic too?
That's true. It is. And this happens sometimes when a manufacturer is not terribly concerned about what the part looks like. In fact, you can actually see, it's subtle, but you can see it. There's some sink right here. And that's because this is such a thick piece of plastic. And it does happen sometimes. Sometimes you do injection mold a thick piece of plastic, but it's pretty rare. And it leads to sink, cosmetic blemishes.
So what do you call it? It's a pattern, that there?
That pattern? Yeah.
Okay. How do you know that's a machining pattern versus a 3D printing pattern?
Well, they just look different, and honestly, it's something that you pick up over time. The 3D printing pattern, you can see individual layers, whereas the machining, they're tool marks. And when I say tool marks, don't be confused, since we are talking about injection molding, and the injection molding tool is the mold that creates the part. That's a different kind of tool. A tool for machining is, it kind of looks like a drill bit. It's called an end mill bit. It's very similar to a drill bit, but a little bit different. And it's that end mill bit that creates this surface pattern here.
Okay.
So this part here, a student asked, what process was used to make this part? And I said, this was injection molded. And the student said, well, how do you know? And so we started discussing, like, what are the telltale signs of injection molding? So one is that you can see there's a fairly constant wall thickness all the way around here. Another is that all of these ribs here, especially because of this central rib all the way around the circumference, there's no other machining or no other manufacturing process that could produce a feature like that other than injection molding. Technically, you probably could machine this, but even if you machined it, you would have small rounds in the corners here, because you're machining your end mill bit is round itself, and it's spinning, it's rotating, and there's no way to create a sharp corner with a round milling bit. So if there are little corners or little radiused corners in there, then you could say, maybe this was machined, but there aren't. And it wouldn't make sense to machine this anyway because it would be a very expensive part unless it was maybe a prototype and you just wanted to make one of them. But that's how I know that this is an injection molded part.
If you found this content helpful, consider enrolling in our signature program at mypipelineacademy.com. Whether you're an individual interested in beginning a new career as a mechanical designer or a company interested in training your new engineering hires, our signature program helps students develop the practical skills they need to be productive mechanical design engineers. Seating is limited. We hope to see you there soon.